Okay, there is a typo here. Over here where it's saying what A, X, and this is supposed to be a B. Okay, so we have matrix A, matrix X, and matrix B. Matrix A is the square matrix of just the coefficients. What's in front of X, Y, or X, Y, and Z. Matrix X is a one-column matrix of the variables. So you'd have X and Y, or you'd have X, Y, and Z. Matrix B is the one column of the constants. So let's, in number 1 and 2 here, we're just going to write them as matrix equations, okay? So this is the matrix equation that, we're going to write it as. So matrix A is just the coefficients in front of X and Y. Okay, you do want the X's lined up and the Y's lined up. And you want each equation lined up and lined up, okay? So this would be a 5 and a 3 are the X's, -6 and 2. So especially when you have like a 3-variable system, if one of the equations is missing a variable in its place, you have to put a 0, okay? But this wasn't missing anything, okay? Then it says this equation up here says we multiply by matrix X, which is just the variables, X and Y. And it is one column. And it equals the constants. So -47, -17. And that is this system written as a matrix system, okay? So let's do it for number 2, which is 3 variables, okay? So the X's, or I can just write the first equation, is 3, 1, 3, okay? That's the coefficients in front of each term. Remember, if it's missing a variable in that place, you have to put a 0. So it goes in the order X, Y, Z. Okay, so the next equation was 2, 1, 2. The bottom equation is 4, 2, 5. Then I multiply it by matrix X, which in this case will be X, Y, Z. It's just the variables. Equals the constants, 2, 1, 5. Okay, so down here we have the same things, okay, but remember this is a B, not a C. That was a typo. Okay? That's all the same. But now we have, it's taking that equation and it's multiplying both sides by A to the -1. So like if you just ignore this for a second, there's the original equation. Then I multiplied both sides by the inverse of A. So matrix A to the -1 power. Okay, that's the inverse of matrix A. When you do that, remember, an inverse times the original whatever, they cancel out to 1, right? So matrix A and the inverse of A cancel out, leaves that left side with just matrix X, but it left the right side with the inverse of A times matrix B. So that's how we can solve for these systems. So if I write the number 3, and I'm going to use this format here, okay, so it wants matrix X, which is the variables, and this is just X and Y, is going to equal the matrix A, which was the coefficients, 5, -6, 3, and 2. And it wants the inverse of matrix A. So I'm going to put that -1 power. And then it's times matrix B, which is the constants, -47, -17. Okay, and then this is where we're going to go to the calculator and solve. So I will show that on the next video. Okay, so in that video, we saw that our answer ends up giving us a matrix that said -7, 2. Now remember, we write systems as a point. So this gave us the point -7, 2. Okay, it's always X, Y. Okay, so now number 4, we write our system. This time it's 3 variables, so it's x, y, z is going to equal matrix A, which is just the coefficients. Remember, if you're missing a variable, put in a 0, but in this problem we're not. 3, 1, 3, 2, 1, 2, and 4, 2, 5. We want the inverse of that times matrix B, which is 2, 1, 5. Those are the constants. Okay, you enter in that in your calculator and Desmos. So our answer, when we typed it in, ended up being the matrix -2, -1, 3, which is the point, -2, -1, 3. It's always X, Y, Z.